I'm just going to make a video finishing these notes out since we didn't get these finished in class. So we were looking at limit definition of a derivative, the general limit definition of a derivative, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. And so this is our general limit definition of a derivative, and we are going to complete this with the function f of x equals x to the third plus 2x. So the first thing we have to do is we have to find f of x plus h. And in this case, that's x plus h to the third plus 2 times x plus h. So we've got to remember x plus h to the third is x plus h times x plus h times x plus h. And then, of course, we'll have the plus the 2x plus 2h if we distribute that h there. Okay. So you've got to multiply two of these together first, so you will get x squared plus 2xh plus h squared. And then you have to distribute here, so you'll get x to the third plus 2x squared h plus xh squared. Then you have to distribute your h, so that'll give you plus x squared h plus 2xh squared plus h to the third, and then I'm running out of room, plus 2x plus 2. And actually, I really should not. Yeah, okay, yeah, keep going. And so you can see this gets really longer. Algebra takes a little while here. And so if you combine your like terms, you'll have x to the third. Let's see, I've got a 2x squared h here and an x squared h here, so that's going to give me plus 3x squared h. And then I've got a x h squared here and another 2x squared here, so I get a 3xh squared plus the other three terms I cannot combine. So h to the third plus 2x plus 2. And so all of this stuff right here, all of this stuff we just found, this is f of x plus h. So it gets really long here. You're going to need a lot of room on your paper for these problems. And so what we've got is we've got the limit as h approaches 0 of x to the third plus 3x squared h plus 3xh squared plus h to the third plus 2x plus 2. All I've done here, this is all my x, f of x plus h. So I still have to put the minus f of x. So I'm going to do that. Minus f of x is just x to the third plus 2x. Make sure you throw some parentheses around that. So we're subtracting the whole thing. And then all of that is over h. And so I'm just, so I don't have to write all this over again, I'm going to distribute this negative. So I've got a negative x and a negative 2x here. And I want to see if there are any terms that I can combine. Hopefully something's going to cancel here. So I've got an x to the third here and a negative x to the third here, so those will cancel. I also have a 2x right here and a negative 2x right here. And I have made a mistake. Typically, one reason I know I've made a mistake is because typically what's supposed to happen is all of the terms in the numerator here are still going to have an h with them. And I can see right here I've got that positive 2, and it does not have an h, and it won't cancel with anything. So that, because I've done a lot of these problems, is alerting me that I've probably done something wrong. And I see what I have done wrong over here. I was supposed to distribute that 2 to this h right here, and I did not write the h down. So I should have an h right here with all of these 2's, which means this 2 right here should have an h with it. So I am left with all of these 4 terms that I have left include an h. So what I'm going to do is I'm going to factor that h out. So I have 3x squared plus 3xh plus h squared plus 2, and all of that will be over h. And then the h on the top and bottom can cancel. So once we've canceled something, typically with our limits, we want to go ahead and plug in our number. Please, please, please remember you're plugging in 0 for the h, not the x. So it's 3x squared plus 3x times 0 plus 0 squared plus 2. And this term will be 0 and this term will be 0. So we'll just get 3x squared plus 2. This is our derivative, f prime of x. So what this tells me here is it gives me the slope of the tangent line at any point. So I've put a graph over here of this graph. This is x to the third plus 2x. And so if I want to know the slope of the graph at 1, f prime of 1, I would just plug 1 in. 3 times 1 squared plus 2 would give me 5. And so I have, because I know more than you, I have created this where it will show me the tangent line. And if I move over here where, well, it already showed up there, but I could move it right there, where my A is 1. Here, let me put this point on here so you can see A, F, A. Alright, so right there at that point, at 1, you can see the slope of this line. If I zoom out a little bit, you've got a slope of up 1, 2, 3, 4, 5 over 1. So that gives you the slope of the tangent line. But it'll work anywhere. So if I want to look at the slope of the tangent line right there at 0, then f prime of 0 is going to be 3 times 0 squared plus 2, which is going to give you 2. If we look at the slope of our line here, up 2 over 1. Looks great. We could, plug in any number and it's going to give us that slope of that tangent line. So this is our answer right here, and it will allow us to find the slope of the tangent line at any point. Alright, let's try another one here. Here's some new notation that we haven't looked at yet. This d over dx, what this means is the derivative of whatever's in the parentheses, or the brackets here, with respect to x. So this d over dx means the derivative of whatever is in this parentheses. In this case, it's square root of x plus, or I'm sorry, those are brackets. It's whatever is inside of these brackets, which is, in this case, the square root of x plus 1. And it's respect to whatever variable you see here with your dx. So this is the derivative of square root of x plus 1 with respect to x. Now, eventually we'll see things like the derivative with respect to y. However, for right now, you really don't have to worry about knowing exactly what that means so much. I just wanted to introduce that wording to you. This just means take the derivative. And right now, the only way we know how to take the derivative is to use our limit definition of a derivative. And not x. Our limit definition of a derivative is limit as h approaches 0 of f of x plus h minus f of x all over h. So for this problem, we are going to plug in our limit as h approaches 0. We're going to plug in x plus h into this equation, which is going to give us x plus h plus 1. So right here for my f of x plus h, I've got this part of the function. Then I'm going to subtract f of x. Well, f of x is just square root of x plus 1. So f of x here, that's our square root of x plus 1. We know that because it's what's on the inside of our brackets here. And then for our limit definition of derivative, we always put this over h. And so to solve this, we need to multiply by the conjugate because we got those square roots there. So we are going to multiply the numerator and denominator by the square root of x plus h plus 1 minus the square root of x plus 1 on the top of the fraction and the bottom of the fraction. So that will give us the limit as h approaches 0 of x plus h plus 1, because when we multiply the square root of x plus h plus 1 times the square root of x plus h plus 1, we're just going to get x plus h plus 1. And then remember, we're choosing the conjugate because it gives us that difference of squares, so the outer and inner terms, those are going to cancel out. But then we'll have minus x plus 1. Make sure you put parentheses around that minus right there whenever you, around that x plus 1, whenever you do that. So we've got all of this over h. So if we distribute our negative here, we've got the limit as h approaches, oh, I messed up here. This is a common mistake. I actually do this a lot. I messed up because I was being lazy up here, and rather than writing this in both places, I just drew arrows. But I was supposed to multiply the numerator and the denominator by that conjugate. So I should still have that conjugate in my denominator. So I should have x plus h plus 1, that should be a plus right there, plus the square root of x plus 1 in my denominator. So if I distribute here, I've got x plus h plus 1 minus x minus 1 all over h times the square root of x plus h plus 1 plus the square root of x plus 1. And in that numerator, the x's will cancel, the 1's will cancel. I'm only left with the h, which I have just an h on the top. And I've got an h that's factored out here, so I'm just going to go ahead, so I don't have to write that twice, I'm just going to go ahead and cancel those h's. Now, I just want to make sure everybody knows I could not do that before everything else canceled, so I am going to write it out, I guess. Limit as h approaches 0 of h over h times square root of x plus h plus 1 plus the square root of x plus 1. And so the h's cannot cancel. A lot of students like to cancel things on top and bottom when they can't. Those h's cannot cancel until you've canceled the other parts. And so now you can plug in 0. So you'll have a 1 on the top, and you'll have the square root of x plus 0 plus 1 plus the square root of x plus 1. Remember there that you are plugging in 0 for h and not for x. So now you've got 1 over the square root of x plus 1 plus the square root of x plus 1. A lot of students have a little bit of trouble combining these right here. Just think what you would do if you did x plus x. It would not be x squared. It would be 2x. This is going to be 1 over 2 times the square root of x plus 1 here. And so that is, actually we don't want to name this f prime of x. This is the derivative of the square root of x plus 1. Okay, the rest of the notes are going to be in a video that you're supposed to watch tomorrow, like I had originally planned. So what I'm going to do, because we did not get done with these notes today, is I am not going to assign a homework assignment that you have to turn in, because I know that you are getting this later, and it might just not be quite fair to ask you to do that. However, I will tell you what the assignment was going to be, and it is helpful to look at these problems. So you were going to have page 131, 11 through 23 odd. I'll write that down over here. Page 131, 11 through 23 odd. Okay, this is not required to turn in. I'm going to get rid of that assignment on Canvas so that it is no longer up there looking like an assignment that you need to turn in. However, if you do want to look at these problems, it won't hurt to look at them. The video that you're going to watch tomorrow is going to have you doing more of this, and for the assignment that you're going to do tomorrow, it's built in that you have to use some of the limit definition of derivative. So if you don't get a chance to do this homework, this optional, not required homework that you don't turn in, then you might want to, you will get some practice with it again tomorrow. If you have any questions, if you do try to do page 131, 11 through 23 odd, and you have any questions, please let me know, and I'll see if I can help you any on that.